Okay, 5.6, example B. I'm going to show you two ways to solve this next equation. So 5.6, example B. All right, there's going to be two ways to solve this next equation, and the one is going to show a brand new property and probably be part of your Do Now quiz. So we have this example, solve 4 to the x power equals 128. Now we've seen these before where we've tried to get the common bases. And this is using properties of exponents. However, even if I got common bases here, I wouldn't be able to solve exactly for x because I know that 4 to the third power is equal to 64 and 4 to the fourth power is equal to 256, which means that x has to equal some number in between 3 and 4. So 3 point something, but I don't know exactly what. And that's what the logarithm, our new inverse operation, is going to help us to figure out. So I'll show you the first way, which is nice because our calculators are able to compute this. And then I'll show you a second way, which if you're using a calculator at home or a phone version of a calculator, you would need to use this property called the change of base property in order to actually compute it, because only our awesome calculators that we have in class are able to compute logarithms with bases other than 10. So here we go. Let me go back and erase this stuff here. So again, the problem that we're solving, it's exactly the same. It's 4 to the x power equals 128, and we are trying to figure out what x equals. So the first way we can solve this, that's probably not going to come up so nice. So the first way is using our property of logs. So first way is just using property of logs. So remember, property of logs was from the other screencast, which said that if I have something where a equals b to the x power, then that's interchangeable as log base b of a is equal to x. So I can rewrite 4 to the x power equals 128, rewriting 4 is b, x is x, and 128 is a. So I could rewrite this where this would be 128 equals 4 to the x power, and I can put that into log form. So log of b, so log of base 4 of 128 is equal to x. And then I can use our TI Inspire, our calculator that we have at school, to actually compute this, because when I hit that control log key, I'm allowed to put in whatever base I want. So if you actually use the calculator and you compute this, you find out that x equals 3.5. And you'd be done with the problem. However, most calculators, and especially one that you would be using on PARCC or any other kind of standardized test, is not going to have this lovely property where you're allowed to put in any base you want for a log. All the calculators you use on any standardized tests are only going to be logs of base 10, which is called the common log, which are the ones we did in the investigation. Therefore, we need to look at a second way to solve this problem. And the second way is a little bit tricky, but it comes up with a nice property at the end that we can then use from here on out. So here's the second way. So the second way, make sure we copy this down, these are part of our notes, is to raise each of our originals here to the power to 10 to that log. So just stick with me for a second. We're going to use inverse functions here. So I'll write 10, the log of 4 to the x power, which is equal to 10 to the log of 128. And this is just using inverse functions. Okay? From here, I can take this exponent here, I'm going to highlight it, this exponent here, which is an x, and put that in front of my log. So I would have 10 to the x times log 4 equals 10 log 128. And that's just using the power of a power rule. Okay, so now we actually have our common base property of exponents. Remember, where I have the same base, I'm allowed to just bring the exponents down and set them equal to each other. So this is common base property, which means I have x log 4 equals log of 128. Now, in order to get x by itself so that I can solve for it, I have x times, right, times, no, not copy, not cut, not any of that, times, there we go, times log to the 4th. So how would I undo to get x by itself? Well, I would divide by log 4. So I'm going to do the same thing to the other side, divide by log 4. So this last step is solve for x. So I'm just going to change colors here because I can, and to just show you that this is going to come up here. So I would get x equals, because this would cancel, log 128 over log 4. And now both of these have base 10, which if you're using a regular old calculator or even a computer calculator or a phone calculator, you'd be able to compute log in base 10 of 128 over log in base 4, or log in base 10 of 4, and you would get the same answer of 3.5, just like we did in the first example. So I hope you wrote that down. This property here, let's see if I highlight, does it go away? This property here is actually a famous property. It's called the logarithm change of base property. So I'm going to just scroll over to the next slide. You pause and go back as necessary. So the second method, really? There we go. The second method uses the, and here it is, the logarithm change of base property. Okay, and the change of base property simply says if I have log of b, no matter what b is, so the log base b of a is equal to the log of a divided by the log of b. And when I don't write the base in, right, there's a base b here. When I don't write the base in, it's assumed that it's base 10. So what I've now done is changed this log property here, no matter what the base is, whether it's 1, 2, 3, 4, 5, 6, 27, doesn't matter. I've changed it into base 10 using this change of base property, where I take the log of a and I divide it by the log of whatever that base is. So that's a new property. Please make sure you also copy that down. One more video. I promise it's not a very long one. Please tune back in to see example C.